Okay, welcome to the first theory lesson of the game development series. We're going to start with geometric modeling. This is pretty much how your game world is made. So, why do we need to know this? Well, we're developing the game engine, and we're going to need to implement geometrics into the engine. So by understanding this process and what it consists of, we will know how to implement it in a fast and efficient way. We also need to know key terminology of the industry. For example, what meshes are and vertices. They're just some of the geometric modeling terminology that you'll come across. And we also need to understand our options, and that was spelled wrong. Once we understand the options that we have, we will know which one will be best for us to implement. So, what's geometric modeling? Geometric modeling is, in essence, 3D models. Anything, not even 3D models as such, any type of model that you input into your game. It can be like a 2D model, like a square, but in our case it's mainly 3D models, because we're making a 3D engine. They tend to be made in programs such as Maya, 3ds Max, Blender. You can make them in Google SketchUp. There's loads of programs out there to make 3D models. In the games industry, they are normally referred to as a standard. They're normally referred to as meshes, and we'll use the word meshes from now on for the rest of this. So, how are meshes used? Well, they used to add pretty much all your objects to your level. For example, you're making a first-person shooter on a spaceship. You'll need the floor of the spaceship, the walls of the spaceship. You'll need like little containers on the spaceship. You'll also need your opponents, any windows you've got on the spaceship, your weapons, your character. Everything you see on the spaceship that's pretty much physical is a 3D mesh. We also need to examine them for performance reasons. Too many 3D meshes can cause a large performance hit. There's normally something called a polygon count, and I'll get into that later. We also need to know how we use them. We'll use an importer later on in the engine. We'll import 3D meshes from programs such as Maya and Blender. Blender being the free version, or a free modeling software. In our case, we're going to use meshes as we're going to program meshes. Very, very basic meshes like squares and cubes. What are meshes made of? They're made of polygons. As I said earlier, games will have a polygon count. In other words, the max amount of polygons that you can have in the world. Polygons are basically faces, in short. Every mesh will have a set number of polygons in them. For example, a square, depending on how you make it, you can make it out of 3-side polygons or 4-side polygons. It'll either be like 6 4-side polygons and more 3-side polygons. I'm not counting that right now. Vertices are pretty much the corners, single points. When you make a mesh, you'll import a load of vertices in, so the corners, and you'll give the graphics card a list of indices. The indices are pretty much the lines connecting the dots. So your graphics card will pretty much play dot to dot until it makes a solid object. For example, the triangle down the corner, it's got 3 corners. So you plot 3 vertices. You would say connect 1 to 2, 2 to 3, and then it will connect 3 to 4 for you. Doing this would then make the solid object with a solid face. Usually in games, we don't just have the basic mesh. Like in the bottom corner, all the meshes, well, all the polygons you see are white. We don't do that in games. We overlay a texture map. This texture map will pretty much give the illusion that it's a real life object. For example, if you have a brick wall, it will look like a brick wall once you put a brick texture on it. Because what's the difference between a brick wall and a stone wall, other than what it looks like? There is not really anything. So that's the basics of geometric modeling sorted. In the next video we will do geometrics in 2D space. Well, meshes in 2D space. If you have any questions of anything that you feel I've missed or not explained very well, feel free to email me. My email is on the screen and will be in the description. If you want to discuss something because you feel like you don't agree with what I understand, also feel free to email me, because I'm learning this as I go along, so there are things that I will not get right, there are things that I will understand really well, and it's a learning process for everyone. If I get corrections or new ways to explain things, if enough people don't understand the video, I'll be sure to remake the video, pointing out new things in different ways. Hopefully that's all you need for today. Feel free to join me in my next video, which will either be later today or next week.